Okay, so here we have another question from an IGCSE paper. This is from a paper 4 of May-June 2009. Question 7 was requested for me to answer this question, so I'm going to go ahead. Now, this question here, we have been told that there's a solid metal bar. So it's a solid metal bar in the shape of a cuboid of length 250 centimeters. The cross section of the square is a side of the cross section is a square, of side x centimeters, and the volume of the cuboid is 4,840 centimeters cubed. We got to show that x is equal to 4.4. Okay, so now we know that the volume of a cuboid is given by length times width times height. Okay, length times width times height. So we can say that the length is 250, and the width is x, and the height is x, and that's going to give us the volume, which is 4,840. So you'll end up with x squared equals 4,840 divided by 250. You can cancel those out. So x is going to be the square root of, make that longer, the square root of 484 over 25. Okay, so we're going to have the square root of 484 over 25, which gives us 22 over 5, which is 4.4. Okay, so that gives us 4.4. So x is equal to 4.4. Okay, x centimeters, 4.4 centimeters. So there we have our steps. Pretty simple. Then it says that the mass of 1 centimeters cubed of the metal is 8.8 grams. Calculate the mass of the whole metal bar. Well, we know that the mass of 1 centimeters cubed is 8.8. So 4,840 centimeters cubed is going to be 8.8 times 4,480. So you can just, it's a simple proportion. Okay, so we can say that we want to find what the mass of, so we can say that 4,840 centimeters cubed has a mass of grams. Okay, and we know that 1 centimeters cubed has a mass of 8.8 grams. So m is equal to, it's going to be 4,840 times 8.8. Now that will give us an answer in grams. Okay, and the answer they want is in kilograms. So be careful about the units. It's very important to be very careful about the units here. Okay, these type of questions, you should read the questions very carefully. Okay, so you have 4,840 times 8.8, which gives us 42,592. 42592. Okay, that's 4,000. Did I write that right? 42592. Yeah, 42,592. What happened there? Okay. That's grams. To convert that to kilograms, you can divide by 1,000. So in kilograms, you're going to get 42.592. Now you can leave your answer like this. This is actually fine to leave it like this, or you can write it to 3SF, 42.6 kilograms. Okay, both of those would be acceptable answers. Okay, in this case, because this is an exact answer, it doesn't continue on and on, so that could be acceptable. But because it's a bit long, you could round it to 3SF. Both of them would be acceptable, and you find them both acceptable in the mark scheme. Then it says, part C, a box in the shape of a cuboid measures 250, so that's 250 by 88 by H. Okay, and we need to find, then it says, 100 of the metal bars, so 120 of the metal bars. So 120 of these metal bars, whose dimensions are 250 by 4.4 by 4.4, fit exactly in the box. Calculate the value of H. Okay, so there's a couple of ways you could do this. I personally think the easiest way is going to be when we, because they fit exactly into the box, there will be no space left behind. So the volume of the container, okay, this box, the volume of this box divided by the volume of one of those bars will tell you how many bars fit in the box. And that will be a way for us to do that, because we know that the volume of the whole container, the volume of the box, is equal to 250 times 88 times H. And that's what we have to find. We know the volume of one bar, okay, which they told us here already. The volume of one of these bars, this cubed, is 4,840 centimeters cubed. This is centimeters cubed. Okay, and if we know that 120 of the bars fit in the box, so the volume of the box divided by the volume of the bar has to be, of one bar, has to be 120. So if I take this and divide it by 4,480, so if I do 250 times 88H over 4,840, that's going to give me 120. Okay, because it says fits exactly. That's the key here. If they didn't fit exactly, then I won't be able to use this because there'll be some space left over. But here, there's no space left over. So all the volume of the box is taken up by the bars. So that's why you can just divide the volumes to find the number of bars. And we already know the number of bars. There's only one thing missing, which is a H. So what we can do here is we can just rearrange this. So H is going to be 120 times 4,840 divided by 250 times 88. And let's see what that gives us. So we're going to have 120 times 4,840 divided by 250 times 88. That will work still. That gives us, one second, let me do that again. 120, let me put, this is a proper fraction, 120 times 4,840 divided by 250 times 88. And that gives us 132 divided by 2, which is 26.4. So the height is 26.4 centimeters. Okay, the value of H centimeters. So 26.4 is going to be the height of the box. Now, there's another way we could do this, because we know the dimensions of the bars. You know that it's 250 by 4.4 by 4.4. So that's one bar. That's like one bar in the box. Just like it's not exact, it's not to scale, of course. Okay, so this is like one bar in the box, something like that. So we need to find what the height of the box is. Okay, so what we could do is we could say, okay, here there's going to be one bar fitting because the dimensions are 4.4 and 4.4 and 250. So we can say that there's one bar fitting in this direction. In this direction, there's going to be 88 centimeters and 4.4 centimeters each bar. So it's 88 divided by 4.4, which gives us 88 divided by 4.4, which will give us 20. So there's 20 bars. There's 20 bars going across this way. Okay, 20 bars, and there's one bar going across this way. So that means the height, the number of bars in the height is going to be, we know there's altogether 120. It's going to be 120 divided by 20 times 1, which is 60. So there's 60 bars, 120 divided by 20, which is 6. So there are 6 bars that are going to be on the height. Okay, so we're going to have 6 bars, and each bar is going to be 4.4. So there's going to be 1 bar this way, there's going to be 20 bars this way, and there's going to be 6 bars that way. That gives us 120. Okay, that's 1 times 20 times 6, that's 120. So 6 bars are going to fit in this height, and each bar is 4.4, its height is 4.4, so you're going to have 6 times 4.4, which hopefully will give us exactly the same answer as 26.4. 6 times 4.4, which gives us 26.4. The same answer, just a different way of doing it. I think this first way is easier, and that will definitely work because they fit exactly. If they didn't fit exactly into the box, then you'd have to use a method like this. Okay, and you'd have to deal with a whole number of bars. Okay, so for example, if on the height, say 6.2 bars fit, well, you can't have 0.2 of a bar, so then you'd have to use 6, and then you'd have to work out in that way somehow. Okay, so because it says exactly, you can use this method, which is perfectly fine. Okay, now for part D, it says one metal bar of volume 4,840 centimeters cubed is melted down to make 4,200 identical small spheres. All the metal is used. Calculate the radius of each sphere. Show that your answer rounds to 0.65 centimeters, correct to 2 decimal places. Now they tell you the volume of a sphere, so that makes it pretty easy. So we can say the volume of one sphere is going to be 4,840 divided by 4,200. Okay, that's the volume of one sphere, because the bar is melted down to make this many spheres, and there's no wastage of material. So the volume of one sphere was going to be 4,840 divided by 4,200. That gives you, I'll just write it in this form, 121 over 105. Keep it in an exact form as much as you can to save accuracy. So I know that for one sphere, 4 over 3 pi r cubed is going to be equal to 121 over 105. So r cubed is going to be 3 times 121 over 105 times 4 pi. And r is going to be the cube root of all of that. Okay, so let me just... Okay, it's basically 121 over 105 times 3 over 4 pi. That will give you the same thing, 3 over 4 pi. Okay, so that gives you 0.275. Okay, and you find the cube root of that. So let me just write what this is. 0.27511. Cube root of 27511, sorry, 27511. And that's the cube root of that. So you take your answer and you find the cube root, which is over here, which gives you 0.65038, 0.65038, 0.65038 dot dot, showing that it continues like this. And we can see that this is going to round to 2 decimal places, as I asked us to show, to 0.65 centimeters. Now, one important point here, when they say show that your answer rounds to something, you have to show your answer to more than that particular accuracy and show how it rounds to that. So don't just go straight from here and write down the answer from your calculator. Write it down to a higher degree of accuracy to show that it will round to what they require. Okay, and always try to keep accuracy in your calculations by using exact values until the end, so you don't lose accuracy marks. Okay, that's D part 1. Now D part 2, it says calculate the surface area of each sphere using 0.65 for the radius. So they don't want us to use a more accurate form of it. They want us to use 0.65, and they told us the surface area of a sphere is given by 4 pi r squared. So it's pretty simple, this one. You just have to just use this and substitute the r with it. That will be the surface area of one of the spheres. So 4 pi times 0.65 squared. And they want us to use 0.65 as 0.65, not as its more accurate value. Okay, so in case I need this later on, I'm going to store this answer as A. Okay, that's the answer for the radius, in case I need it in more accurate form later. But let's just see, 4 times pi times 0.65. Whoops, 65. 0.65 squared, I should say. Okay, 4 times pi times 0.65 squared, which gives us 169 over 100. Okay, so that's, let's write it in this form, 169 over 100. 169 over 100 pi. And if you write that to 3SF, you get 5.309, 5.31. So you're going to get 5.309, which gives you 5.31 centimeters cubed. That's the surface area of each one sphere. Okay, now calculate the total surface area of all 4,200 spheres as a percentage of the surface area of the metal bar. Okay, so we've got to find the surface area of all 4,200 spheres, so that the surface area of the spheres is going to be 4,200 times, let's just take this value here, the one that they told us to take 0.65, so I'll take that, 169 over 100. That will give me the surface area of all the spheres. So you take that and multiply it by 4,200. That gives us 7,098 pi. So 7,098 pi centimeters squared is the surface area of all the spheres. And the surface area of the metal bar. Now remember, the metal bar was the surface area of the bar. Okay, remember the metal bar, it was 250 by 4.4, that was 4.4, that was 4.4, and that was 250. So the surface area, remember, is the area of all the faces. So if you think about it, you have this square on one side and on the other end. So you're going to have two of the squares, which are 4.4 times 4.4. That's the area of these two faces. And because they're all square faces, all these rectangles here will be the same. Okay, you'll have 4 rectangles. Each of them will be 250 times 4.4. So 4 times 250 times 4.4, that's the area of one of the rectangles, and that's the area, that's 4 of them, and that's the area of one of these faces, and that's the area for both of them. That should give me the surface area of the bar. So you're going to have 2 times 4.4 squared plus 4 times 250 times 4.4. And that should give us, it gives us 4438.72. 4438.72 centimeters squared. And they want us to find the total surface area of all the spheres as a percentage of the surface area of the metal bar. So you've got to have the surface area of the spheres as a percentage of the surface area of the bar. And you multiply that by 100%. So whenever they want the percentage of something, the percentage of the surface area, they want the surface area of the spheres as a percentage of the surface area, whatever's after the word of is going to be the denominator. So the surface area of the spheres is 7,098 pi, and the surface area of one of the bars is 4438.72. And to change that into percentage, you multiply by 100%. It looks like it's going to be more than 100%, and that actually makes sense, and I'll explain why in a minute. So that's the numerator, and the denominator is 4438.72, and you multiply that by 100, and that gives you 502%. 502% to 3SF, so that's 502%. It was 502.38 carried on like that, but it's 502%, and that's the answer. And some people say, how can it be that it's over 100%? Well, if you think about it, if you take an object and you slice it, okay, into two parts, even if you take a cuboid and slice it into two cuboids, you're going to be having more surfaces. So if you take this, you make lots of spheres out of it. The amount of the object that is exposed to the surface is going to be more. So you make little bits out of something big. You're exposing more of the inside of it to the surface, so its surface area will increase. Okay, the surface area will increase. So that's one of the reasons why this is bigger than 100%, because you're taking this and you're taking lots of little spheres, making it into a lot of little spheres, so the area that's exposed to the surface is going to increase. Okay, so that's how you could understand why, and I think that's the end of that question. Yep, that's the end of that question, and I hope that was clear. Thank you for watching.